Hello everyone and welcome to class. In today's cybersecurity analyst course, we'll be looking at network protocols and the basic types of network protocols that we have. So we've looked at network protocol severally and the definition we've given to it. We talked about the fact that set of rules by which devices communicate on the network. So much more than that, a network protocol describes the order of delivery and the structure of the data. So what they basically do is to tell the receiving device what to do with data. So a network protocol doesn't just describe the rules of engagement for both parties to be able to communicate. It also provides a kind of a common language for two devices to communicate. So where we talk about protocols now and network protocols is, let's imagine we have two devices communicate with each other, or let's even look at the word devices. Maybe it's big for you. Let's look at two people that want to communicate now. One person can speak Spanish and one person can speak English. So now, naturally speaking, both of them cannot communicate to each other because the person speaking Spanish, once he's talking, the person speaking English cannot understand. Rather, you might misinterpret what the person speaking Spanish is saying. To avoid that, it's very important that either both of them speak English or both of them speak Spanish. And that's where it comes to the fact that they have to agree on the rules of the language to communicate, so that they will not be communicating the wrong things to each other. So that's how it works really. In network protocols, we look at the type of engagement or the form of engagement that we use, and also basically protocols also carry information, basic information. And this information tells the device or receiving device what to do with the data that you are sent to it. Now let's look at three types or categories of network protocols. So we are just dividing it. There are a lot of protocols, a lot of protocols. We've looked at several of them when we're talking about the TCP/IP model and also the OSI model. We've talked about HTTPS. We've talked about I don't think we talk about ICMP, but we talk about HTTPS, we talk about TCP, we talk about UDP, we talk about the SMTP protocol and other protocols like that. But yeah, we want to look at them by grouping them in categories. The first we'll look at now is the communication protocols. So this is to ensure effective communication between two devices, and communication protocols uses a suite of protocols. Remember, protocol enable communication, protocols enable delivery, protocols enable swift communication between the two devices. Now, for these two devices to be able to send data to and fro, they have to dictate what data to be transmitted and also the timing of the communication between them. And that's why we have the two main protocols here as TCP and UDP. In the TCP/IP model, we talked a little bit about TCP, and in the OSI model, we're able to talk more on TCP and how TCP is very effective in ensuring communication between two devices. So one advantage of TCP is the fact that it has a way of being able to relate information when it has not been sent, it has not completed its course. So we basically call that the automatic repeat request, where it's able to if data does not arrive its destination, transport uses automatic repeat request to transmit the loss of data. So basically, that's why TCP is effective, because it ensures that data gets to its intended place. So for this to occur, really, we will discuss a little bit about the three-way handshake. When you access a device through the application layer, remember the TCP/IP model, the OSI model, you use the application layer as an end user. When you approach a device, one thing is very sure: you don't even know the level of communication that goes on. But let me just explain a little bit about the communication. You make a request. Maybe you request for a particular information, like you send a request for the name of the website that teaches software development, data analysis, and maybe you also made a request for cloud engineering. Now, having done a request, you're expecting to see a list of answers, possible answers given by search engine, depending on the kind of device you use, whether the Mozilla browser, the Google Chrome browser. So in the last topic, that was the OSI model, we're able to explain effectively. That's why if you don't have the OSI model note, go and listen to it again. Effectively, what really happens in the application layer, in the sense that the web browser works with the three main layers: application layer. It also works with the presentation layer and works with the session layer. So these three layers are able to effectively make sure that communication works through. Now, since we know this, through the application layer, you're able to make a request, and it just goes down until it gets to the TCP under the transport layer, where information is being sent. For an internet communication to occur, there has to be a protocol that will do that, and that's TCP, and it allows us to have two devices to connect, to form a connection and stream data easily. So there's what we call a three-way handshake, and let's talk about that. This three-way handshake, the client, let's talk about you as the client that is making the request. So you are making a request to a server. Remember, you asked the question, where can I study software development? Which website can I be able to browse and learn software development, cloud engineering, data analysis, and all of that? You have made a request. The request is going to the server. So through the HTTP connection, I'm sure you did HTTPS google.com, and you did that through your web browser. Then you are able to ask, where can I? So you use the search engine to be able to pick the request and begin to search for the query. Now, once you search for the query, the first thing it does is to send a request. That's how the TCP that's how the three-way handshake starts. It sends a request to the server. Then, simple as ABC. Hello server, can you open the connection for me? Very simple request. Then that request is sent is called a SYN segment, SYN. SYN, like to synchronize, SYN segment. So once you send that for synchronization, the server is able to acknowledge the fact that a request has been made, and it returns with a message of SYN ACK, SYN ACK. So once the server replies with SYN ACK to tell you, I received your message, guy, I received what you asked for, and I'm going to reply. The next thing is to, after acknowledging, is to also ask the client that if I'm going to reply, you must open up to me. That is when it sends a SYN ACK, so SYN for synchronization and ACK for acknowledgement. Then the client, that is you, through the browser, your browser, we have to reply with acknowledgement also. So once the acknowledgement is replied, then secure connection has been established. So this is a three-way handshake, but it happens in split seconds, so you don't really observe something has happened, but that's how it happens. The three-way handshake: send a request, acknowledge the request, sends back SYN ACK, then acknowledge the fact that, yeah, I'm ready to open up for you to make a connection. So I'm asking you for a connection. You say, hey, I received your message. All right, you too, are you ready to open up? Let's connect. Then you open up, then the connection is made. So it's as simple as that. So once the server receives the final act from the device, TCP connection is established. So in the TCP IP model, TCP occurs at the transport layer. Even the OSI model too, TCP still occurs at the transport layer. The UDP is under the, we talk about two main protocols under the communication protocol. UDP is very important. We've talked about that also. Yes, where we talk about the fact that UDP is very fast. And when you are talking about reliability, you should be talking about TCP. When you are talking about non-reliability, just for faster communication, then we don't talk about UDP. UDP is user datagram protocol. It's not as fast, it's not as reliable as TCP, but it is very, very fast. UDP is very, very fast. So basically, that's under communication too. We have HTTP, like you used to make a request, hypertext transfer protocol. Then we have the DNS. DNS is very important. And why is it important? Because DNS is the one that translates your domain names, the internet domain names, into IP addresses. So I'm sure if I tell you the name of my website is djtconcept.ng, so you are able to easily access that by going to www.djtconcept.ng, or you do http then s.//:djtconcept.ng. It's easier to remember, right? Because the domain name, human understandable English language name. What if I tell you my website name is 119.212.313.4? It's very easy to forget, right? And you even think something is going wrong. That is what is really being used. So once you type in the domain name, the DNS will convert that to IP address easily. Because what happens is when a client computer wishes to access a website domain using their internet browser, a query is sent to the DNS server. That's what they do. And the DNS server looks up on the IP address that corresponds with the website domain. So it does not send the request through the domain name. It looks at the IP address that actually corresponds with that domain name. So every domain name has a specific IP address. Remember, I explained to you that IP address is used to access the internet. So when you are actually not in the same network, you are going across different networks, then you need an IP address. So IP address is attached to every device to be able to communicate with each other as long as they are not on the same network. So for you to communicate, there needs to be an IP address. The DNS to convert to IP address so that it can be easy for communication. Then the management protocols. This is the next category of network protocols. This is what they call the management protocols. They are mainly used for monitoring and managing activity on the network. We've talked about that a little bit. I don't know if you can still remember. Just try and check your notes. We've talked about the management protocols, and in the management protocols we talked about it a little bit during when we were discussing the session. And we said session has some management protocols that it works with. So management protocol, we have the SNMP, Simple Network Management Protocol. We have the ICMP, Internet Control Message Protocol. I know some of these things are looking much for you to grab, but it's not compulsory you remember all the names. It's however essential you know what the names do and what they really are for. SNMP is for monitoring and managing devices on the network. So when you want to monitor a device on the network, then you are talking about the SNMP protocol. It's a protocol that is used to monitor devices on the network. Same thing with ICMP. This was an internet protocol that is used by devices to tell each other about the data transmission across the network. The data transmission, including the errors. So the ICMP is very important also. It's used to tell each other on the data, about the transmission errors and how the data is really flowing. So ICMP is commonly used as a quick way to troubleshoot network connectivity and latency by issuing the ping command. So in the TCP/IP model, the ICMP of course at the internet layer is more like an IP layer. It actually does this ping. So when we continue in the class, we get to a point. The ones we don't discuss in depth now, we'll still discuss them later where they are most needed. So the ICMP really is where we have the ping. So there's what we call when you ping a device. You can ping a device to be able to know what the error of the device is, or the location of the device, or different things about the device. So sending a ping is through the ICMP. We'll talk about that more. Don't be agitated at any point you don't get. We'll always get back to it. Remember, we have talked about HTTP now, for example, more than so many times from the beginning of the class, so that you hear the word again and again and again, and then it becomes familiar with you are familiar with it. I expect by now you should be familiar with words like HTTP, HTTPS, SMTP. You should know what the protocols are for. Application layer. You should also be familiar with basic TCP, IP address. You should be able to know what an IP address. We talk about the fact that IP issues a specific address to devices to be able to communicate. We've talked about that. So we've mentioned it several times. So the more we talk about it, it sticks and you're able to understand. Always brush up on your notes from time to time. Security protocols. That's the next one we'll talk about. So we have talked about three main protocols. The first protocol we talked about is the communication protocol, for communication to happen within two devices. We've talked about the management protocol, the one that manages and monitors devices on the network, and the one that also pings and checks for error across the network. Then security protocol here is where we have network protocols that ensure data is sent securely and received across devices securely. In the OSI model, if you can remember, we talk about the fact that under presentation layer we can see the HTTPS. So why? Because once you send a request across the application layer, then presentation layer is able to present down the line what you've sent. And remember, it doesn't send it as words and text, but in binary form. It's able to bring it down, does the translation and transmission, and is able to bring it down. Once it brings it down, you're able to it's able to take it down to the other layers called the presentation layer. At the presentation layer now, is able from application layer takes it down to presentation layer. Presentation layer is able to present it by translation and transmission, like what I just said now. And also it does encryption. In encryption now, it encrypts the data from the sender down to the receiver. So more like as it enters the layers, it encrypts the data. After the application layer, it encrypts the data, then it sends an encrypted data down. And once you get to the last layer, the network, the physical layer, it also encrypts it back. So it's encrypting to and fro. So because of the encryption, it adds this S to it, HTTP. HTTP, we now have S. The S is for secured. The S is for it's a socket layer. So we have the SSL, that's the secure socket layer, or the TLS, transport layer security, that performs encryption on transmissions that that goes across devices, so that the bad guys, the threat actors, the malicious actors won't be able to access that. Before the end of the course, we will talk about ports and port numbers. Every device works at a specific port. Port 80 is for HTTP, but 443 is for HTTPS. So HTTP port 80 is generally known not to be secure, but HTTPS is the secure version. Okay, now we have the file transfer protocol, FTP. That's file transfer protocol. But to be secure, we have the S behind the secure file transfer protocol. That's the SFTP. So the simple way to understand, so that when you are transferring files from one device to over a network to your server, it can use secure protocols to ensure that device is sent securely, or sent as an encrypted device, encrypted data. Now the same thing we have with SMTP. We can have SMTPS, and the security is important across devices, so that is the goal. The only reason why you are learning communication across network protocols and all of this is to be able to understand how threat actors can be able to take advantage of the network, form a man-in-the-middle attack, or form any form of attack. When you understand the process, then you understand how to secure the process. You cannot secure what you don't understand, and that's why we always make it compulsory for you to really understand the concept and the core concept that goes behind communication, and goes behind how data is being transported from one form to the other. Once you're able to understand that, then you can now understand the layers at which are less secure, the layers at which hackers can come in and cause mayhem. Then you understand all of that. So as we progress, we will still understand some basic protocols. There are still some other ones. The NAT, network address translation. This one, okay. So if you have devices in your local home, they all have different private addresses that they use to communicate directly with each other. So for the devices with private devices to communicate with the public, they need to have a single IP address that represents all of the devices that is going to the public. So what does this mean? If in my local network now, I have several system, printer, and all of that. If I'm communicating across the same network, it's easy. You can easily even communicate with our MAC number of the device. Now remember MAC number again. I've said it several times before. MAC number is that specific number that is given by the manufacturer of the product. It's written. If you check your laptop or check any of your devices, you see the MAC number there. The MAC number is for you to communicate across the same network. But when it's going across the internet, then we need the IP. So what the NAT does is to be able to convert your basic home device network, into what it can be able to move out on IP, like be able to communicate with an external IP. So if some of these things are still confusing you, don't worry. We'll talk about them much more as we move along. So just absorb this first, and learn more on your own also.